Hi, my name is Osman. I am a middle school mathematics teacher in Houston, Texas. I am also the author of the book Sequences and Series. I have written this book because I believe I have discovered a new formula which helps us to find any term of any degree sequence. My formula is similar to Newton's formula. I will explain it in detail, but I want to share a short story about myself before I explain it. When I was a senior student in the university, when I was in Turkey, one day I accidentally discovered a beautiful pattern between the perfect squares. The perfect squares are 1, 4, 9, 16, 25, 36, 49, 64, etc. I will share my screen to show it. Okay. The perfect squares are 1, 4, 9, 16, 25, 36, 49. 1 is equal to 1 squared, 4 is 2 squared, 9 is 3 squared, 16 is 4 squared, 5 squared, 6 squared, and 7 squared, comma, 3 dots. That keeps going. The pattern I mentioned was 3 squared is equal to 2 times 2 squared minus 1 squared plus 2. 4 squared is equal to 2 times 3 squared minus 2 squared plus 2. 5 squared is equal to 2 times 4 squared minus 3 squared plus 2. That recursive pattern keeps going. So the 6 squared will be equal to 2 times 5 squared minus 4 squared plus 2. And when I discovered this, I was so excited. I immediately went to the number theory professor's office in the university. The professor asked me two essential questions about my formula. The first question he asked was, where are these coefficient 2's are coming from? And the second question he asked was, where are these constant 2's are coming from? I said, I don't know. I accidentally discovered it. The professor advised me to go search up all formulas about the sequences and series and figure out if that was already discovered before or not. And I did. I kept studying sequences and series for 5 years until I came up with my own formula, which is this. Before I explain it, I want to show where these coefficient 2's and constant 2's are coming from. Let's write down these perfect squares again. So 1, 4, 9, 16, 25, 36, so that we can look at the differences between the consecutive terms. Now, the difference between 1 and 4 is 3. Difference between 4 and 9 is 5. So 16 minus 9 is equal to 7. 25 minus 16 is equal to 9. And 36 minus 25 is equal to 11. These are the first differences. The difference between 3 and 5 is equal to 2. Difference between 5 and 7 is equal to 2. And 9 minus 7 is equal to 2. 11 minus 9 is equal to 2. As you noticed, the second differences between the perfect squares are all equal. All of them are equal to 2. And that's because the perfect squares form a quadratic sequence. If you have a quadratic sequence, then the second differences of it must be common. So the constant 2's are coming from the common difference between the perfect squares, 2. The second question professor asked was, where are these coefficient 2's are coming from? Coefficient 2's are coming from the Pascal's triangle. Pascal's triangle is 1, 1, 1, 1, 2, 1, 1, 3, 3, 1. And if you have a linear equation, the coefficients of your equation must be 1 and 1. So 1 and 1 are the coefficients of a linear equation. If you have a quadratic equation, the coefficients of it must be 1, 2, and 1. So 1, 2, and 1 are the coefficients of a quadratic equation. Since perfect squares are forming a quadratic equation, the coefficients must be 1, 2, and 1. We see 2, the coefficient 2, but where are these 1 and 1? If you multiply a number by 1, it is equal to itself. 1 times any number is that number. So 1 times 3 squared is itself. 1 times 4 squared, 1 times 5 squared, 1 times 6 squared. You can also multiply these perfect squares by 1 as well. 1 times 1 squared, 1 times 2 squared, 1 times 3 squared, and 1 times 4 squared. When you look at the coefficients horizontally now, 1, 2, 1, 1, 2, 1, 1, 2, 1. The coefficients are 1, 2, and 1. That's because that sequence is quadratic. So as a result, the coefficient 2 is coming from the Pascal's triangle, and the constant 2 is coming from the common difference 2 between the perfect squares. Okay, the formula I mentioned in the beginning of the video was this. You can pause the video and read it. I will just explain what are these unknown letters are representing. In this formula, n is representing the degree of the sequence. For example, if you have a quadratic sequence, the degree of it is 2. And if you have a cubic sequence, the degree of it is 3. X is representing the term you are looking for. Term we are looking for. Let's take a look at an example such as this. 1, 4, 9, 16, 25, 36. The perfect squares. And let's say we want to find the 15th term of it. So we want to find f of 15. F of 15 is equal to, since quadratic sequence, the perfect squares are forming a quadratic sequence, we need to substitute 2 for n. So 2 plus 1 times, we are looking for the 15th term, so we need to substitute 15 for x. 15 minus 1 combinations of 2 plus 1 times the parentheses. In the parentheses, we need to use the binomial expansion. So, the binomial expansion, which is 2 combination of 0, 2 combination of 1, and 2 combination of 2. Some say 2 choose 0, 2 choose 1, 2 choose 2. But it is easy for me to say 2 combination of 0, 2 combination of 1, 2 combination of 2. Then we need to multiply 2 combinations of 0 by f of 3, because we need to substitute 2 for n. 2 plus 1 is equal to 3. So f of 3, that's going to be f of 2, and the last one will be f of 1, because we need to use the first 3 terms of the sequence. 1 is f of 1, 4 is f of 2, and 9 is f of 3. So multiply 2 combinations of 0 by 9. Then over 15 minus 2 plus 1, because we need to substitute 2 for n, minus multiply 2 combinations of 1 by 4, then divide it by 15 minus 2. And plus, it goes by minus, plus, minus, plus. So plus 2 combinations of 2 times f of 1, which is 1, then divided by 15 minus 1. When you calculate this, you are going to get f of 15. F of 15 will be equal to 15 squared, which is obvious. You might be thinking that much work is not necessary, but that's a simple sequence. As the sequences gets complicated, the formula I mentioned here might be very useful. My formula can be the alternative of the Newton's formula. So normally when we find the n term of any degree sequence, we use Newton's formula. Newton's formula use the first term of the original values. First term of the first differences. First term of the second differences. And first term of the last differences, which is third differences. Basically, Newton's formula used the first term of each row. So we multiply 4 by 15 minus 1 combination of 0 plus 9 times 15 minus 1 combination of 1 plus 12 times 15 minus 1 combinations of 2 plus 6 times 15 minus 1 combinations of 3. When you calculate all of them separately and add them up, you will get 3,406. That is the method everybody knows. The method I mentioned, let's solve this question, the same question with the formula I mentioned. What is the 15th term of the sequence below? 4, 13, 34, 73, 136. Again, we need to substitute 3 for n because the sequence is cubic. Why? Because the third differences of the sequence are equal, common. So 3 must be substituted for n. Since we are looking for the 15th term, we need to substitute 15 for x. So f of 15 is equal to 3 plus 1 times 15 minus 1 combinations of 3 plus 1 times the parentheses. In the parentheses, we need to use binomial expansion. 3 combinations of 0, 3 combinations of 1, 3 combinations of 2, 3 combinations of 3, which is 1, 3, 3, 1. Multiply 3 combinations of 0 by f of 4, which is 73. And multiply 3 combinations of 1 by 34, that is f of 3. 13 is f of 2, and 4 is f of 1. Then divide the first fraction by 15 minus 3 plus 1. Why 3? Because the sequence is cubic. We need to substitute 3 for n. 3 plus 1 is 4. 15 minus 4. 15 minus 3. 15 minus 2. 15 minus 1, respectively. When you calculate it, you are going to get 3,406. We got the same answer using the Newton's formula, 3,406. As I said, this formula can be the alternative of the Newton's formula. This formula might have been discovered by somebody else before. In that case, if anybody lets me know that this formula is already discovered, then I will edit my book and remove my name from the formula. Thank you so much for watching the video. I will make another video to show the proof of the formula I mentioned. Stay safe. Bye.